Sorry about that weird cutoff, but again, we're looking for the x max, the x min, the y max, and the y min. So we see that we have the 0 to 24. So since we have that 0 to 24, and that's going to be my x values, my x minimum is 0 and my x maximum is going to be 24. For my y minimum and my y maximum, we have that the max depth is 17 and the minimum depth is 7. So I'm just going to start my y at 0, and then we're going to go up to about 20. I like to give a bit of room on either side. Now, what is the depth of the water to the nearest tenth of a meter at 2 a.m.? So, T stands for time. And I have that D at T, or rather in this case, it's going to be D at my 2 a.m., will equal, and then looking back at our equation, 12 plus 5 cos 0.5 all multiplied by that 2. Now, very, very important. Remember that we are in radians right here. So, this will give me a solution, or this will give me an answer of 14.7. So the depth of the water is 14.7 meters at 2 a.m. The next one. A ship which requires a minimum of 8.5 meters of water is in harbor at midnight. By what time to the nearest meter must it leave to prevent grounding? So it has to have a minimum of 8.5 meters of water in the harbor. So we get 8.5 equals 12 plus 5 cos 0.5 t. Now, when you guys were in a situation where you had to solve something like this, what did you do? You graphed it. So we get y1 equals, and I'm just going to write this slightly rearranged, 5 cos 0.5 t plus 12, and my y2 will equal 8.5. Doing this will give you guys a graph, again using the window settings that we previously stated. You'll get a graph that looks something like this, and then that 8.5 line cuts through it like that. So we want to know at what point we won't get grounded, and that's going to be the first intersection that we have there. So you go second, intersect, enter, 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 make sure to move the cursor closer to that, and moving the cursor closer to that, what you're going to get is you're going to get an x value of 4.7. Problem is, this 4.7 represents the x value. It's not necessarily time. So I have to convert to time. And what the 4.7 means is it's 4 a.m. and then we have 0.7 of an hour. So I multiply that 0.7 times 60, and that gives me it's 4:42 a.m. So the ship would have to leave by 4:42 a.m. What's the next time that the ship can return to the harbor? So we look for that next intersection right there, and we find that that happens at 7.9. I need to figure out what the time is, so I go 0.9 times 60, and that gives me 7:54 a.m. So the next time would be 7:54 a.m. Moving on to the next question. Estimate to the nearest tenth the depth at 4:15 p.m. So we notice here again, I run into that problem with the 4:15 p.m. I need to take that and I need to convert it into the decimal. Well, I have 15 minutes of the 60 total minutes, so that would give me 0.25. So this would represent 4.25. Since it represents 4.25, I substitute that into my equation. So I'm looking for h at 4.25, and this would give me 2.10 sine. Now you have to be careful of the brackets right here. Otherwise, you may make a slight mistake. And putting this in, this gives me 4.4 meters. So the depth is 4.4 meters. Estimate to the nearest minute, one time in the day where the water is 2.9 meters deep. Again, we get into this exact same situation where I'm going to have my y1 would equal 2.10 sine 2 pi t minus 3.25 all over 12.4 plus 3.4, and my y2 would equal 2.9. So punching this in to my calculator will give me a function that kind of resembles something like that. Sorry, my lines were a bit shaky right there. But we're looking for that point right there. And finding that, we get that it's at x equals about 2.8. So again, I take that 0.8 and I multiply it by the 60 minutes. And that means that it'll be at 2:48. 2:48. Okay, we'll get to the last questions in the next video.